Okay, we're going to quickly talk about what we did for our cheat sheet. So I'm going to write cheat sheet here because that's what we're working on. Is this a function? Yes, we talked about how this is a function. It would pass the vertical line test. So when I start talking about domain, I'm thinking about my x values. We talked about this before. My x values, anything that x can be. So if I'm looking at this graph on the left hand side here, I have a point here, and they're connected. X is everywhere that there is a line. So I'm going to quickly draw the possibilities for x fall between these two lines. Okay, it's like a number line that tells me what x can be. So if I'm reading off of my x-axis here, this is negative 16. This is positive 16. X is everything in between there. So when I look at this in terms of an inequality, which is how we show this a lot of times, we we say that x is everything between negative 16 and positive 16. And it's all of these things, not just whole numbers, but fractions and decimals and all of these tiny little values. There's a bunch of numbers x can be. So in this case, x is everything between positive and negative 16. We show that like this. So negative 16 is less than or equal to x. That's the left side here. X is everything greater than negative 16. But we have to put a stop on it. So I'll say x is everything less than positive 16. So that tells me x is in between negative 16 and positive 16. And it also includes those two values. All right, let's switch to our y. In this case, range is all of my y values. All right, well, what can y be? Y can only be one number. That number is positive 2. There's no other y values because there's no other lines on this graph. So y is equal to 2. And the reason it's equal to 2 is because that's the only value that it can be. Let's keep going. Got another set here. Yes, this is a function. So let's look at the values that x can be for my domain. X is everything in between negative 2 and positive 7. X is everything in between there. So we're just going to, let's look at what we had before. I have a compound inequality here, an inequality with two sides on it. So I'm just going to put that here, okay? I have negative 2 is less than or equal to x. And then I have to put a stop on that. So I'm saying right now, everything, x can be everything larger than negative 2. Okay, but then I have to stop it, and I have to stop x at 7, and that's what that shows. Okay, so let's look at this one. My y values range from there to there. So my range is between that span, that number line for that green. Well, what's my lowest here? It's 0. And what's my highest? It's positive 12. And I'm just reading that off of the graph. This is 0, and this is positive 12. Okay, so y is everything in between there. So my lowest point, my minimum, we say in math, is 0, and that is less than y, and y is less than 12. Again, less than or equal to, excuse me. Y is everything larger than 0 and including 0, but I have to put a cap on the top of it. It stops at 12. All right, let's look one more quickly again. These we talked about on Thursday and Friday. Yes, this is a function. Yes, yes, yes. So I'm going to start to look at my domain. Remember, I'm looking at everything x can be. All right, there's negative 8. There's negative 1. X is everything in between there. I'm going to use that compound inequality again. Negative 8 is less than or equal to x. And that's cool. So I'm saying x starts here and goes to the right, but it has to stop, and it stops at negative 1. Okay, x is everything in between negative 8 and negative 1. Let's look at our y values. We all agreed on Thursday and Friday that positive 7 was my maximum for my y. Where we started to get a little convoluted was some people looked right here at this dot and said, oh, negative 1 is my y here. But that's not true, folks. I'm looking for the lowest thing y can be, and it's somewhere along here. So if I were to look at this, I'm going to roughly state that this is -1.5, okay? And it's somewhere between -1 and -2. It's somewhere in between there. We'll call it -1 and 1/2. All right. So y is everything in between there. Boom. So the range goes from -1.5, and you can put -1.5 there, is less than or equal to y. So y is larger than this number. Remember, the mouth eats the bigger number. And then y has to be less than or stop at +7. No sweat. We're feeling good about this. Let's zoom out a little bit and we'll go to this one on the back. We're going to look at this one here. Okay, we're going to look at this one. Scratch that. This one here. All right, why are we going to look at this one? Because this one still is a function, but I have a crazy domain now. If I start thinking about my x, I don't want to keep it in between these 2 points. And I don't want to keep it between these 2 points. I want to think about everything that x can be. So when I think about that, this goes in a negative direction forever. And not just in the y, but in the x. It's going to continue to go left as far as it can go. And it's going to continue to go right because it's going to be 4, then 5, then 6, then 7, and so on and so on. As this gets larger and continues out, it's going to continue at 6, 7, 8, 9, 10, and go on forever. Okay? And it's going to continue to go to negative forever. All right? So we can think about this as negative infinity, positive infinity. We could use this notation. Again, we talked about this might not possibly be the best notation. You will see this sometimes, but for me, Mr. Ford, what Mr. Ford likes is all real. Let me write that so it looks like the actual word, real numbers. Okay, so my domain is all real numbers. And that's what we write. We write the words, 3 words, all real numbers. All right, so let's look at our y values. The y values are roughly the same. Don't limit yourself to these 2 points here. Don't do that, because then we're just thinking 1s or 2s. We don't want to think that. I want to think about this again. This is going to continue in a negative direction, -2, -3, -4, all the way down to negative forever. And it's going to continue up 10, 11, 12, 13, 14. It's going to continue up until infinity or forever, whatever you want to think about that. So again, I go from negative infinity to positive infinity in terms of my range. So I'm going to again say my range this time is all real, not real numbers, real numbers. Struggling. All right, last one, and then this is it. We're going to look at this, and we call this array. And I know this is a terrible, terrible way of looking at this. So maybe let's do this one instead. So this is similar to array. I have a point, and then it goes down, and then it goes up. So is this a function? Yes, this is a function. So let's talk about my domain. My domain starts here, or ends here, I guess you could say. And it goes this way, and it goes left forever. So this is 1, and this is negative infinity. So I can think about this as it is x is anything that's less than 1, 0, -1, -2, -3, -4, because this arrow on the end tells me it's going to continue to go. Yes, it's going up, but it's going left as it's going up, and it's going to be -3, -4, -5, -6, negative a million, -10 million, negative infinity. So we could write this 2 ways. Negative infinity is less than or equal to x. So any x is greater than negative infinity. And x stops at 1. Or I could just leave this part out, this negative infinity part out, because it's kind of redundant. X is everything less than or equal to 1. That includes all of my values all the way to negative infinity. What's the most negative number you can think of? Negative infinity. So again, it's going to be anything x, anything less than negative, or excuse me, anything less than positive 1. My y values, my range, it starts here. This is my minimum. This is the lowest y can be. And it continues that way until positive infinity. It's going to continue up. It's going to be 6. It's going to be 8. It's going to be 10. It's going to be 20, 50, 90, a million, 20 million, a billion. What's the biggest number you can think of? However, it is no lower than 0. This is 0 right here. So y cannot be less than 0. It can be 0. It can't be less than 0. So again, I can write this as 0, because that's my minimum, is less than or equal to y, and y is less than or equal to infinity. Now, again, this is kind of redundant, so I can leave this less than or equal to infinity off, and I can just say 0 is less than or equal to y, meaning y is anything 0 or more, which is what we want, right? Here's where 0 is, and y is everything above that. Remember, don't be blindsided, or don't have your blinders on looking at this point here at 1, 1, because y is down here. There is a value at 0, 0 that is your y value there. So y can be less than 1, but it can't be less than 0. That's my minimum on my graph. All right.